Hello students, in this session we will discuss about an overview of deductive databases, which is another enhanced data model that are used with database systems. So what is this deductive databases? So the term deductive database is actually coming under the research area artificial intelligence, where we are deriving some or deducing new informations from the existing set of data that is already being stored. We are applying some deduction rules such that the database, from the available database, some new informations can be gathered. We are not having the direct data available, but from the available data some new information can be gathered. So there are various other sub research areas under this deductive concept. Deductive actually coming under this like machine learning, or what you say, it is actually part of an artificial intelligence research area. So what is this declarative language? So we are going to discuss about a language that is declarative language, which normally specifies some set of rules. Some set of rules will be specified. Maybe these rules are represented as part of database, and based on these rules we can gather some additional information. So first of all, we need to follow a declarative language for representing these rules, and also we need to have some queries, so that based on the query we can retrieve the information that is already existing, and also we can retrieve something extra from the available rules by applying some queries. Similarly, we require an inference engine or deduction machine. For these deductive databases, we require an inference engine or deduction machine which can deduce new facts. Deduce means it can represent or produce a new fact or some number of new facts by interpreting the already existing rules. So first of all, we can specify rules. Second, by using inference engine, we can deduce new facts from the available set of rules, or interpreting the two different or different number of rules that is already available. So this inference engine or deduction machine is based on, or it is related to logic programming. And logic programming, we were using a language called as Prolog, that is programming logic. Prolog, the name arrives from programming in logic, Prolog, which is used to make inference engine based on various declarative or rules, different rules that are represented by using declarative language. And it is using backward chaining to evaluate, that is, it is following a top-down application of the rules. That means if it gets a rule, it is actually doing a backward chaining. It is having a comparison with all the statements that is already available within the set of rules which is already stored in the deductive database system. Now, for this inference engine or deductive database system, we need to specify or represent different contents in two different formats. One is by using facts, and second one by using different rules. Facts and rules are used for representing the different specifications of a deductive database system. So what are these facts? Facts are similar to relation in a normal database system, and we cannot say that without the necessity of including attribute names. In relational databases, what we are doing, for each attribute, roll number we are having a value, name we are having a value, salary we are having a value. But facts, in the case of deductive databases, we are representing some facts. we are representing some facts, because like for example, Raju was born in 1980. It is a fact. It is the representation, but we are not specifying any particular attribute over there. So it is not necessary to have some attributes, and corresponding to the attributes we can write a fact. It is not mandatory. Any statement can be represented as a fact. Second one is a set of rules. It is similar to, so facts are similar to relation table, then rules are similar to relational views, virtual relations that are not being stored. Rules, some set of rules that are based on the available data. So we are having some data available which is exactly stored. Then we are defining some rules which are not exactly stored, similar to views in normal databases, but these view contents can be utilized for deriving some information from the existing facts. So we are storing facts, we are also storing rules. Facts as a relation table, rules as a separate virtual table. Now we will be discussing about the representation of these facts and rules in Prolog or Datalog notation. Prolog is the language that is programming in logic. Datalog is a similar language, so it is almost following the same format. That is why we are written like Prolog or /Datalog notation, so that we can they are following almost similar syntax for both of these languages. Now these two Prolog or Datalog, it consists of a predicate. So all the notations in Prolog is in the form of a predicate which has a name, a predicate name, and a fixed number of arguments. So there will be a predicate and a fixed number of arguments. This is the format of representing a predicate. A predicate name, P, we can give any name, then we will be having some number of arguments depending on the situation. Now the convention is constants are numeric or character strings. So if you are having some constants available within this predicate, they are represented by either some numeric like numeral values or by using some character values. And if you are using some variables, it must start with uppercase letter. So if I am writing Raju, it will be like first letter must be capital letter. The variable must start with capital. So Raju cannot be a variable, but I have simply given, for example, if I am using a variable x, it must be in capital letter, and if I am using HA is as a variable, H must be capital. So a predicate is having a predicate name, then a number of arguments. We will see examples. Now the basic conventions like constants are represented by using either numeric or character strings only, and variables usually starts with capital letter. Now one example we will see. This is the predicate supervise. Within argument I have written supervisor comma supervisee. So supervise is the name of predicate. This is the first argument supervisor. This is the second argument supervisee. We can see that the capital letter initial, the variable starts with capital letter. So supervisor is a variable. Supervisee is also a variable. That means we can change the values here. So at one particular moment, this supervisor will be a person. We can assign a value for this variable, and for supervisee also we can assign a value. So these two are variables, and this is the predicate name, that is supervise. The meaning is supervisor supervises supervisee. So first argument is related to second argument. How? First argument supervises second argument. That is the way of representing a predicate in Prolog or Datalog language. I hope it is clear. Supervisor supervises supervisee. So this was the representation of a predicate. Now how we can represent a rule in Prolog or Datalog? So a rule can be represented. So all the facts are represented in predicate format, in this format, like predicate within bracket multiple number of arguments. Now a rule can be represented in the form of head colon hyphen body. Head colon hyphen body. So this symbol actually indicates, it is actually read as if and only if. Head if and only if body. That means head is true if and only if body is also true. That is the meaning of this statement. Head is true if and only if body is also true. Okay, so this is the representation of rule. So we will see one example rule. Superior of x comma y. That means x is superior of y if and only if x supervises y. So I am defining a new rule. I am writing a new rule, a general rule based on the available predicate, that is, if x supervises y, if it is true, I am writing a head, that is, x is the superior of y. Okay. Similarly, you can see another rule, subordinate y comma h. This y and h is being reversed here. Now y is the subordinate of h if and only if h supervise y. The same thing. Based on the same body, we are defining a new head, that is, y is the subordinate of h. When it will be happening? When h supervises y. I hope it is clear. Based on, so we will be having some real facts available in predicate format. Then we will be having some rules available that is being generated based on available set of predicates. So that by referring these facts and rules, some new informations can be deduced. Now we need to have some query representation. So based on these facts and rules, if you apply some queries, then only we can retrieve some information. So involves a predicate symbol followed by y, some variable arguments to answer the question. Okay, so it involves a predicate symbol followed by y, some variable arguments to answer the question, where colon hyphen is read as if and only if in the case of rules. Okay, so now it won't be clear. We will see how we can represent a query. So for example, this is a query. So all the facts and rules are already written. Now I will be in Prolog. What is happening is like SQL prompt, there will be a question mark symbol available. There we can type, it is a prompt actually, where we can type this statement, superior of James comma y. It is the query. In sometimes it is represented a question mark over the end, superior of James comma y. That means whether, so y is a variable because it is capital letter, James is a constant, it is entirely small letter. So whether James is superior of y. So we need to refer all the available facts available. Similarly, subordinate of James comma h, whether James is subordinate of h. A query will be entered in this format. It will be referring to the facts and rules, and if it is correct, it will be forming, it will be getting a result like yes or y by checking the facts and rules. So these are example formats of writing queries. We will see the different examples. Okay, So we will see some examples and how it can be represented by using a supervisory tree. The same facts, how it can be represented by a supervisory tree. So these are the facts available, real facts available. Listen: supervise Franklin John, Franklin supervise Ramesh, Franklin supervise Joyce, Jennifer supervise Alicia, Jennifer supervise Ahmad, James supervise Franklin, James supervise Jennifer. So these are the facts that is already being stored. So in Prolog, all these details are entered and saved. These are already stored. All the facts are now available. Now some rules are also being created and that is being stored. That is superior x comma y if and only if supervise x comma y, as in the previous. The same statement is taken here also. If x is superior of y, x is superior of y if and only if h supervise y. That rule is written. Then another rule that is also written: x is superior of y if and only if h supervise z and z is the superior of y. In that situation also, so we can combine more than one predicate in the right hand side, that is in the body part, so that these conditions satisfies, so that the left hand side also satisfies. So I can say h is superior of y if h supervises z and z is the superior of y. In that situation also x and y is related. How? X and y, they are superior. So y, h is superior of y. It is through z, that's why. In that way also, so we are defining a rule for that. Then one more rule that we are setting is subordinate of x comma y. That means h is subordinate of y if and only if y is superior of h. That was also discussed before. That rule is also being defined. So representation of these facts in the tree format: James is having two subordinates, Franklin and Jennifer, these two. Then about Franklin, three subordinates, John, Ramesh and Joyce. And about Jennifer, two subordinates, Alicia and Ahmad. So this is the exact tree structure of the same thing. Okay, so this is just for understanding. So in an organization, the employees are having these types of hierarchies: one superior, subordinate, then further subordinate, superior, etc., etc. They are connected. So these things, some available data are there with direct constant values, and some of the rules that can be set generally by using variables, so that later we can replace these variables by using some of the constants when we are applying some queries. Now later in the prompt we can apply a query like superior of James comma y. So this is the query that will be entered. In real Prolog, what will happen is superior of James comma y, superior of, so it will first look into the facts whether there is any such statement available, superior of James comma y. No, it is not available. Then it will look into the facts, superior of James comma y. So it will just convert that this James into this sets, superior of James comma y. It will check here. It will check here like supervise of James comma y. It will first replace with all the value. That means first of all it will replace, look into James Franklin, supervise x comma, supervise James comma Franklin. It is true, so it will form a true first. Then it will replace y with Jennifer. That is also true. So it will have all the combination. It will replace that variable with all the combinations that is already available there, and accordingly it will produce a true or false result if it is being matched. Then only this query will be true. So every query in Prolog usually produces a true or false value or yes or no value, whether that statement is correct or not. So what we are doing is we are setting some facts, we are writing some real facts, hundreds of facts we are writing and stored in database. Then we are writing a number of rules, then that is also stored virtually. Then whenever we apply some query in deductive database system, whenever we apply some query, when we type some query, the query will be in predicate format. Then it will go for direct checking into the facts in the database. If the fact is directly available, for example, superior of James, Franklin was the query, it will directly say yes or true. Now if it is with a variable, it will assign all the corresponding values, and if everything is true, it will produce a true as the result of that particular query. And it will also check for other rules also. It will compare that with all the rules, and if it is correct with all those rules, it will produce a true or false value. So Prolog is a language which is used for programming in logic. It is used for representing facts and rules in real life. Several facts can be written, and we can also write some set of rules based on the available facts in predicate format, and later we can do some querying. We will type some query, we will enter some query, and based on the query we can come into a solution. That means whether a particular statement is correct or not. It is based on the available set of facts and rules. So this is only a simple example. We will be having hundreds of facts to be represented. We should have some certain number of rules that is also to be created, so that the statement may be working in a proper format or in a better way in different situations. In all the set of rules, the statement must be true, otherwise it will produce a false answer. I hope it is somewhat clear. Now when we come into Datalog alone, we will be having slight differences in the representation. Datalog, almost they are following the same format. In Datalog, program is built from atomic formula in the form there. So there it is usually called as atomic formula. All the statements that we are writing is called as atomic formula. And in that atomic formula in Datalog, the literals are represented in the form as P of A1, A2, up to AN. It is almost similar to the previous case. Predicate, then arguments. So P is the predicate name, N is the number of arguments. So we will be having some number of arguments. So Datalog, this portion is same. Then in Datalog, one difference is it is using different built-in predicates. So Datalog consists of different built-in predicates, so that we can apply some of the symbols like less than, equal to, etc. For example, less than 10, 20. It is a built-in predicate. We are applying less than. So this statement is true. Without referring into the roots of facts, it will automatically say, depending on the constant value, it will display true, because 10 is less than 20. So we are having some built-in predicates available within Datalog. Now in this Datalog, a literal, that is this format, is either an atomic formula in this format or an atomic formula preceded by not. So here not only the positive, the negative also possible. That means negative predicate can also be possible. Not A1, not P of A1, A2. That means the negation of that. That is also possible. Now we will just look into the clausal form and horn clauses which are followed in Prolog or Datalog. Now before moving into that, a formula can have some quantifiers like universal quantifier and existential quantifier. You might be familiar about these two terms. For all, for universal. Universal means for all. It is true for all. It is false for all. Existential means there exists at least one. At least one. Universal for all. Existential at least for few. Okay. So these are actually quantifiers. So what is the clausal form? In a closal form representation of a formula, it must be transformed into another formula with some characteristics. So in Prolog it is a very long topic where to convert a normal formula into closal format, so that there will be some changes that is to be added into the existing formula so that it can be converted into closal form. So for several purposes we require the conversion from traditional form into closal form. So what is happening is, to convert that into a closal form, a formula must be applied some of the following, or we should have some of the following characteristics. First thing is, a formula is in closal form if all variables are universally quantified. So all the formulas must be applicable for all, that is universally quantified. It must be applied for all categories. And the formula is made of a number of clauses where each clause is made up of literals connected by logical ORs only. So in the formula, each clause must be connected only by using OR. So if there is no OR available, we must convert that formula into such a way that there must be only the connected literal as only OR. So first of all, make it as universally quantified. Second, connect all the clauses by using only OR symbol. Then third one is, clauses themselves are connected by logical ANDs only. So a formula is made up of number of clauses where each clause is made up of literals connected by logical ORs. Each clause is made up of logical ORs only. Then these different clauses, entire clause must be connected only by using logical AND only. Okay, so we are not studying in detail, just study these characteristics, how we can convert a normal formula into closal form. Now, any formula can be converted into a closal form by following the above conditions. Now, a specialized case of closal form is called as Horn clauses. Horn clause, which is another clause similar to that means a specialized form of closal form is called as Horn clause. That means that contains no more than one positive literal. So exactly, a Horn clause must consist of one positive literal. The result must be always positive. When a closal form is converted into that format, it is called as a Horn clause. So you can study the definition of Horn clause here. Now normally the Datalog programs are usually made up of only Horn clauses with only positive literals. Now interpretation of rules. So as I was mentioning before, we are having different number of facts and rules. So rules are written. So how we can interpret the rules that is already available within the deductive database system. There are two methods that we are following for interpretation of rules. One is called as proof theoretic and second one is model theoretic. We'll just see what is the difference between these two, proof theoretic and model theoretic. Now in proof theoretic, the facts and rules are axioms. They are actually conditions. The facts and rules are axioms. That means different predicates, traditional basic predicates only, true or false. The statement with true or false answer. It consists of only such type of axiom only. Now ground axioms contains no variables. So basic first set of rules that contains only constant values. That means we cannot include any variables for the ground axioms. So basically we require some ground axioms, ground rules without having any variables. Now, rules are actually deductive axioms. Now, when we form rules, we are adding some variables where that can be deduced. We are replace that variables with some other value which is already available with our facts. So, basic axioms are only represented by using ground axioms are represented only by using constants. Then similarly, rules will be having variables. Now, deductive axioms can be used to construct new facts from existing facts. Now, deductive axioms, that is the new rules that is generated, can also be used for constructing new facts from existing facts. We will see one small example, and this is actually called as theorem proving. So, assume that we are having some, this is a fact, this is a fact, this is a fact, this is a fact, and this is a rule, this is a rule, this is a rule. For example, generally I am saying this for understanding. Now, I am reducing a new rule based on the available facts and rules. A deduction, a new rule is being formed, and I am forming one more rule based on these facts and these rules. And these new set of rules can also be used for proving new informations. That is actually called as theorem proving. So this interpretation of rules is generally called as proof theoretic. Now, we will see how we can prove a new fact. Now, we will see the rules available are superior of x comma y if and only if h supervise y. H is superior of y if and only if h supervise z and z superior of y. This is rule number 1, this is rule number 2, and these are ground axioms. These two are the ground axioms, basic with constants. Jennifer is supervisor of Ahmad. James supervises Jennifer. These two are ground axioms. Then, after applying rule number 1 on 3, I am getting a new rule, that is Jennifer is superior of Ahmad. Jennifer is superior of Ahmad. It is very clear. See, if H supervise Y, automatically this will happen. So, if Jennifer supervise Ahmad, Jennifer is superior of Ahmad. The same thing. So, we are forming a new rule. Similarly, applying rule, so here it is by applying rule 1 on 3, we are getting this statement. Then apply rule 2 on 4. Applying rule 2 on 4. Supervise James, comma Jennifer. Supervise James, comma Jennifer. So we are applying rule 2 on 4 and 5, and also superior of Jennifer and Ahmad. So supervise, so here James and here Jennifer. Then superior, here Jennifer, Z will be replaced with Jennifer and Y with Ahmad. So automatically we are forming a new thing, James and Ahmad, they are also related. So applying rule 2 on this 4 and this 5, we are getting a new rule, that is James is superior of Ahmad. So this is the way in which we are proving some statement, whether a new statement is true or false. Now second type of interpretation of rule is by using model theoretic. That is, in this particular interpretation of rules, it is given a finite or infinite domain of constant values, and we assign the predicate every combination of values as arguments. So we assign the predicate so we will try to match with all the constants that are available with the predicate that is already there in the set of facts. And if this is done for every predicate, it is called interpretation. So for every predicate, a set of constant values are given, and these constant values are assigned for every predicate, for every values, and based on that, if you are getting some new information, that is actually the method followed in model theoretic. And if it is done for every predicate, it is usually called as the term interpretation. Now here, model an interpretation for a specific set of rules. A set of rules can be interpreted in different or in adding different values to form a model. Now in model theoretic proof, whenever a particular substitution to a variables in the rules is applied, so if any variables is being substituted, so only difference is we are applying all the substitute value we are trying with all the substitute values with the available values with all the predicates available. Now from there we are getting a model whether it is true or false. So whenever a particular substitution to the variables in the rules is applied, if all the predicated are true under the interpretation, the predicate at the head of the rule must also be true. If everything is true for all the combination of values, then the head side will also be true. So previous case in proof theoretic, we are not doing that. We are only applying certain changes, certain values are being substituted. But in model theoretic, all the possible constant values that are given will be applied to the variables, and if all combinations are true, then only the head side will also be true. Now when we can call a model as minimal model, it cannot change any fact from true to false and still get a model from these rules. Then we can call it as a minimal model. It cannot change any fact from true to false and still get a model for these rules. Then we can call it as a minimal model. At least one is true. So we can say we will see one minimal model, that is an example even almost similar to the previous case itself. We are having some rules available. Superior of x comma y if and only if supervised x comma y, superior x comma y if and only if supervised x comma z, and superior of z comma y. Interpretations: supervised Franklin comma John is true, supervised Franklin comma Rem is true, supervised Franklin comma Joyce is true. So all the interpretations are being done. So this is happening with model theoretic. And finally, supervised x comma y is false for all other possible xy combinations. That is the conclusion. So it is actually applying these constant values to these variables for all the cases that are available, and for all other cases it will be false according to the currently given situation. Now based on this, we are actually deriving some new set of facts. So we are getting this much true information. So from that we can form different facts. We can derive a number of other facts based on different values. That is, Franklin is superior of John. Franklin is superior of John, because you can look into the previous case. It is based on these two rules. Similarly, we are forming a number of other true facts, and we are forming all the derived true facts, and we are finally concluding with all other combination of xy with superior of x comma y will be false with all other conditions. So this is an example for minimal model. So you need to study the two interpretation of rules. One is by using proof theoretic, direct representation, checking and whether it is true or false. Then second one is model theoretic. We are taking the combination of all the we are applying all the combinations, substitution for the variables, and identify all the truths and assume that all others are false. Based on that, derive the new facts with true and we are concluding with saying all other combinations are false. So we cannot change any fact from true to false and still get a model for these rules. That is actually called as a minimal model. So that's it for this session. So we were discussing about another enhanced data model called as deductive databases. Here we need to specifically focus on the representation of data in deductive databases. We are taking a specific language, a query language called as Prolog or Datalog, where we are representing rules and facts. So you have to study the representation of facts, syntax in predicate argument format, then the representation syntax of rules, how rules can be represented, how constants can be used, how variables can be represented, then what is the importance of facts and rules in this learning purpose. Then we are representing different representation of elements in Datalog. Then we have seen what is closure form and horn clause in short. Then we have seen interpretation of rules by using two methods, one by using proof theoretic and another by using model theoretic. So this is only a very small introduction to deductive databases, but we need to study a lot, so that then only we can understand the different other features of this predicate language called as Prolog. But just for understanding, this portion is enough, and this is actually in relation with the database where we are representing the data in a different format. That is the thing. In object databases, we are representing the data in a format. In spatial database, we are using a different format. In temporal database, we are using a different format. In deductive databases, we are using a format followed by the facts and rules. So in that way, we have to approach this subject now. But if you want to study more detail, at least you need to study one full subject for this entire Prolog. So now it is actually not required for this particular subject. So just go through the basics and understand the representations, and try to give some examples for these facts and rules and deduction of new rules by using Prolog or Datalog language. Thank you.